Hi everyone, I am Silvia. I am a PhD student here at the Department of Geosciences of the University of Padova. And I'm doing this video because I won a prize for my master thesis that I did with Professor Giulio Ritoro and Giorgio Pennacchioni with the title Estimate of Surface Energy from Microstructural Studies of Pseudotachylyte-bearing faults. So the objective of the thesis was to analyze the energy budget of an earthquake because for what we know, that it's actually quite few information, the result is that the seismic energy is dissipated in lots of energy sinks, and just a few goes into the actual seismic waves. So we can have both energy that goes into frictional heat that generally forms pseudotachylites. There are rocks that are formed by frictional melting on a rock surface, as for example this one, and also fracturing process in the fault surroundings. So what we did was to go in the Adamello. There is the batholith here in the Italian Alps, and sample one of these pseudotachylyte-bearing faults in the Gole Larghe fault zone. And we wanted to study the areas both on and surrounding the fault to understand the microstructures and actually the microfracturation of the rocks. This because the energy that goes into fracturing is usually calculated as proportional to the surfaces of these microfractures, while the energy that goes into heat can be calculated from the thickness of the pseudotachylyte vein. From the samples, we did thin section both from the region on the fault and also in the host rock that was surrounding the pseudotachylyte to see the variation of the microfracture pattern from near the fault vein going toward the host rock. So what we did was then to take these intersections and analyze them with the SEM, and thanks to cathodoluminescence, actually we were able to spot actually the true microfracture pattern because this is not visible in backscattered images, also taken with the SEM, but also on the optical microscope. So with this technique, we were able to detect them. And what we saw was a striking difference from the northern part with respect to the southern part, speaking of the orientation of the microfractures. So this is likely reflected by the fact that the microfractures were generated by the transient stresses that are associated with the passing of the rupture on the fault, meaning that they are actually generated by the earthquake. And this allowed us to then use them to calculate the energy that went into fracturing and also in frictional heat. This work was actually also recently published into an article on the Earth and Planetary Science letter journals. And I really want to thank both Giorgio Pennacchioni and Giulio Ritoro for helping me in this work.